Hi, good morning. This is Trina here to discuss the third lecture of thermodynamics. So today I am going to discuss about the second law of thermodynamics and the entropy. And you have, I hope that already you have gone through all the study materials for the first lecture and the second lecture. Still, if you have any doubt, you can communicate with me. And I have given in the personal information, my mobile number and the email ID. So if you have any doubt, you can communicate with me. And the most important part, that is the course page, here I have uploaded the entire study materials, the probable questions, semester questions, and the solved problems. So I hope that already you have registered with the given code, that is DMBC. So when you entered with this code DMBC, then you can access all the study materials. And the subject chemistry, the subject code is CH101 for odd semester, CH201 for even semester. This course is for undergraduate BTech students, and the streams are CSE IT Civil Mechanical for even semester and Electrical EC BME for odd semester. And the credits are 3, contact hours 35, and weekly I will take the 3 lectures. The prerequisite knowledge required, the 12 standard to understand the concept of thermodynamics. And about the course objective, the students will learn the several concepts of chemistry. And in the outcome, the students will be able to apply the fundamental concepts of thermodynamics in different engineering applications. So here, the lecture plan are given, entire lecture plan given, so that you can understand that which topics will be covered in which day, so that you can go through the study materials, the related study materials, and you can interact, you can ask the questions accordingly. So, I am continuing the module 2, that is the use of free energy in chemical equilibrium. Use of free energy in chemical equilibrium. So already I have covered 2 lectures. First, it is the basic concept of thermodynamics. Different systems, open system, closed system, and the isolated system. And you have learned the macroscopic properties, that is the intensive properties and the extensive properties. And you have learned different processes like the isothermal process, adiabatic process, isochoric process, isobaric process. You have learned different processes. And in the second lecture, you have learned the first law of thermodynamics and the correlation with the enthalpy. And also you have learned, you have solved the problems on enthalpy. You have calculated the enthalpy of the reactions. Now in this topic, the third lecture, you will learn the entropy and free energy and the second law of thermodynamics. So, why we need the second law? What you have first, you recapitulate what you have learned in the first law of thermodynamics. Okay, so what you have learned that there is no energy or work can be created or destroyed. So there is only change of the energy from one energy to another energy, or energy to the heat energy, work to the heat energy, like that. And you know the expression, that is the W proportional to Q, and we got that W is equal to JQ. And for the form of the first law, that you know that Q is equal to del U plus W. And del U, or it can be the internal energy, can be represented as del E. Del E plus W. W is the work done and Q is the heat energy. Okay, so now I will tell about the second law. So although all natural process must take place in accordance with the first law, still it is inadequate for explaining certain behavior of a system. We know that it is the inadequate, okay, all the processes, natural process, should be explained by the first law, but actually practically it cannot be done. It is inadequate for explaining certain behavior. What are those? I am giving the example. Like one is the burning of coal. Burning of coal, that is the coal burns with oxygen to produce CO2 and ashes. But coal and O2 cannot be produced by mixing ash and CO2. So it is not the reversible process. Basically, coal is burned in presence of oxygen, we get CO2. But CO2 and ashes, the products, from this mixing the ash and CO2, we don't get the reactants, the O2 and the coal. Okay, it is one of the example. Next, another example, flow of water down a hill. So flow of water down a hill is spontaneous, but water cannot flow uphill. So these are the irreversible process. These are not reversible process. So irreversible process, they are the spontaneous process. So all this observation concludes that first law is not enough in explaining all the natural phenomena and reactions. There is need of second law of thermodynamics. Okay, so you can understand why the second law of thermodynamics is required. So what is the statement of second law? Now see that all the spontaneous processes are thermodynamically irreversible. So basically the irreversible processes are spontaneous. So it is going to the equilibrium stage and it is a rapid process. Okay, so all the spontaneous processes are thermodynamically irreversible. So you got two examples, like the flowing of the water downward direction. Another, you got the example that the burning of coal. So both are spontaneous process and they are irreversible. That means we cannot get the reactants from the product. Okay, so this one is the first. Now, the second one is the complete conversion of heat into work is impossible without leaving a permanent change elsewhere. Okay, so the complete conversion of the heat into work is impossible without leaving a permanent change elsewhere. So, we know that conversion of heat into work we have seen. So it is telling that it is not impossible. So always there must be a permanent change. Somewhere there will be a permanent change. Okay. And the third one is the Clausius statement. Basically, the second law of thermodynamics can be explained in different way. So as per Clausius statement, it is impossible for a self-acting machine unaided by an external agency to transfer heat from a body to another at higher temperature. Okay, so we know that the higher temperature to the lower temperature, that is the spontaneous process. But say, like the transfer of heat uh, from the lower to the higher temperature, so we require some act or some permanent changes. So we need some external agent to do this. So it is not the spontaneous, it does not occur spontaneously. So you have learned the second law of thermodynamics. Now, entropy. Entropy is represented by S, that is the measure of the randomness. So the second law leads to a definition of a new thermodynamic property called entropy. And it has been derived from the Greek word entrop, means change. Okay, so it comes from the word entrop, that means change. The change in this property is used to determine the direction in which a process will proceed. That means it will tell that the process is spontaneous or not. It is the measure of unavailability of heat to be converted to work. The change of entropy of a system is defined as the integral of all forms involving heat exchanged divided by absolute temperature during each infinitesimally small change of the process being carried reversibly. So it is telling about the mathematical representation. So how we can represent that ds, the change of entropy, is equal to dq reversible, dq, the change of heat energy reversibly, divided by T, the temperature. That is the expression of entropy. Okay, so now what are the characteristics of the entropy? Entropy is a state function. That means it does not depend on path. It is an extensive property. So you know that what is intensive, what is extensive property. Okay, so it depends on the, extensive and intensive we get when it depends on the mass or not. So it is in a reversible adiabatic process that dq reversible is equal to 0, ds is equal to 0. Okay, so if for the reversible process we know that dq reversible is equal to 0. So if we put here dq reversible is equal to 0, automatically ds will be equal to 0. For an irreversible process, ds naught is equal to dq irreversible by t. Okay, so you have learned the different characteristics of entropy. Now you will learn the physical significance. So physically, entropy is a measure of disorder of a system, or you can say the randomness of the system. So when a gas is heated, it is Q reversible is positive. That means if a gas is heated, so you tell that randomness will increase or decrease, or it will remain same. Yes, it will increase. If we provide the heat energy, so all the materials will get the energy. So the randomness, the movement between the gases will be increased. So we can say the Q reversible, that is the positive. So the intermolecular attraction between the gas molecules decreases. They will be more chaotically distributed, or disorder of the system will be increased. And when the disorder or randomness will increase, we can say the entropy will be increased. Okay, so here you can see the disorder of the system will increase, thereby del S will increase. As long as the spontaneous process in a system continues its randomness, its entropy goes on increasing. And when the process reaches the equilibrium state, entropy becomes maximum and there is no further change in entropy. At equilibrium, del S is equal to 0. So you got the what is the significance of entropy. So it is the basically the randomness of the system. So if randomness increases, that means the entropy also will be increased. Now next is Clausius inequality. So you know that the second law I have described in the light of Clausius theorem. So here, what is the Clausius inequality? So first let us consider the differential form of first law of thermodynamics. So what you got in the first law of thermodynamics, that is du, you got that dq is equal to du plus pdv. You got it. Now what it is? What you got? You can remember, that is dq is equal to du plus pdv. Okay, that was the first law of thermodynamics. So now from this law we got that du is equal to dq minus p external, the external pressure dv. Now equation 1 is valid for both reversible and irreversible process. Now for reversible process, du is equal to dq reversible minus pdv. So you are writing the same, only you are writing that dq reversible. And also you know, instead of dq reversible, you can write T ds. You have got this relationship with the entropy. Where you got it? You have got here. That is the ds is equal to dq reversible by t. So now we can write dq reversible is equal to, from here, okay, from here we can write that dq reversible is equal to ds into t. And put this value dq reversible in this equation. So here we are getting, instead of dq reversible, we are getting t ds minus pdv. Now from equation 1 and 2, we have that dq minus p external dv, that is from the equation 1, is equal to dq reversible minus pdv. That is from equation 2. So both here we are getting that from the equation du, that is the change of internal energy, we are getting the left hand side is equal, that is why we are writing the right hand side also is equal. So we are writing that dq is minus p external dv is equal to dq reversible minus pdv. Now take the q at the left side, that is a dq reversible minus dq is equal to p minus p external into dv. Okay, so now if P minus P external greater than 0, the system will expand spontaneously. Okay, you can understand that the external pressure, that means the pressure minus the external pressure. Okay, so the actual pressure of the system minus the external pressure, if it is greater than 0, the system will expand spontaneously and dV is greater than 0. So if the system pressure is greater than the external pressure, you can understand that it will go spontaneously, it will expand spontaneously. So the system will expand spontaneously. Like say for a balloon, okay, if the internal pressure, that is the pressure of the gases, are greater than the external pressure, then it will expand spontaneously, or you can take it for the piston also. So dV greater than 0, or we can say if P minus P external is less than 0, the system will contract spontaneously, and dV less than 0. In both cases, P minus P external dV greater than 0. Okay, so you can understand that is the system pressure is less than external pressure, or we can say the P minus P external less than 0. So it will contract spontaneously. It will not expand. It will contract because the external pressure is higher than the system pressure. Therefore, dq reversible minus dq is equal to TdS minus PdV, that is greater than is equal to 0, or TdS greater than dq, or ds greater than dq by t. So this fourth number of equation is called the Clausius inequality. Okay, so you got this equation. Now the change in entropy for reversible process. So for the reversible process, the ds system. So first, if we calculate for the universe, the entropy for universe is equal to the entropy for system plus the entropy of the surrounding. That is the sum of entropy of the system and the entropy of the surrounding. So here you can see for the reversible process, the ds universe, the entropy of the universe, change of entropy universe is equal to 0. But for change in entropy for irreversible process, that is d universe greater than 0, since q reversible greater than q. And for finite change, it is for the reversible process that ds universe is equal to 0. Okay, so you have understood. Now you do some numerical problems. So problem 1, if 1.6 gram of methane reacts with oxygen gas to form water and carbon dioxide, what is the change in entropy for the universe? Okay, so you know that the change of entropy of the universe is the sum of change of entropy for the system and change of entropy for the surroundings. So first write down the reaction, that is methane plus O2, we get CO2 plus H2O. Now you know that for the system it is equal to the entropy for the products minus entropy for the reactants. So now write down these values and you can calculate the entropy for the system. Next is, you can also calculate the enthalpy for the reaction. Already you have learned in my previous lecture the enthalpy for the reactions is equal to the entropy, total entropy of the product, enthalpy of the product minus the enthalpy of the reactant. So here we have done this. So next, we are calculating the entropy, change of entropy for the surrounding. That is equal to change of enthalpy divided by T. So here you can write the change of enthalpy. That is basically the Q reversible. Okay, so write down for surrounding, you will get the value. And here, so you got for the system and you got for the surrounding. So you got the entropy for the system, also you got the entropy for the surrounding. Now you can calculate the entropy for universe, that is equal to the surrounding minus the entropy for surrounding minus the entropy for system. So the universe, you can now calculate the entropy for universe is equal to this one. So here you are getting the value. You can calculate the entropy for universe in this way. Okay, so go to the second problem. Second problem, what is it? Calculate the entropy change in surroundings when 1 mole of H2O liquid is formed under standard condition. Okay, so here you have to calculate the entropy change in surrounding. So what is the equation? Entropy change in surrounding is equal to Q reversible divided by T. So T is Q reversible divided by T. Okay. Now, how we get the value of Q reversible? So here the Q reversible we are getting by the change of enthalpy that is given here, change of enthalpy, that is minus 286 kilojoule per mole. So that is the value is 286 and 000 as we converted the kilojoule into joule per mole, and the temperature will be given. Okay, and the temperature will be given, that should be converted into the Kelvin. You add 273 with the degree centigrade, you will get the Kelvin value, and ultimately you can calculate the result. So in this way, you can calculate the change of entropy for the surrounding, for the universe, and for the system. If you can calculate for the surrounding and for the system, then you can calculate for the total, that means the sum, that is for the universe. Okay, so what you have learned today, if I like to summarize what you have learned today. So you have learned that the inadequacy of the first law, where it cannot explain some phenomenon, natural phenomenon. Then the statement of the second law, the Clausius statement, and also you have learned the entropy. And when it is positive, that means the randomness increases, that is the spontaneous process. And when it is negative, the entropy, change of entropy is negative, that is not spontaneous. Okay, and also you have learned that all the irreversible process is the spontaneous process, like the flowing of water from the higher altitude to the lower altitude, or we can say the burning of carbon in presence of oxygen. So it is the irreversible process, as we don't get the oxygen and the carbon from the ash. Okay, so it is the irreversible process and it is the spontaneous process. So we have learned all these things. So you go through the study material well, and you will get more and more problems. You try to solve all this problem. The similar type of problem and different problem, when you will calculate yourself, your conception will be more clear. Okay, so you submit the assignment, you solve more and more problem. If you have any difficulties, any doubt, you can communicate with me. Okay, so for today, I am ending the session, and thank you everyone.